All right, so thus far, you guys have learned how to solve a quadratic equation by factoring. We've done so much factoring, especially before we left school, that you should be able to do it in your sleep. Hopefully, you still remember how to do it. But something we started realizing as we were solving by factoring is as the leading coefficient kept growing and getting larger, it became more and more challenging to factor it. And I've kind of touched on the fact that sometimes factoring isn't the most efficient way to solving a quadratic equation. Sometimes it's more efficient to use other strategies. So this week we're going to start learning a new strategy. This strategy is called completing the square. You are going to learn in the upcoming weeks how to solve a quadratic equation by completing the square rather than factoring. Now, before I teach you how to solve a quadratic equation by completing the square, I first need to teach you how to rewrite it into completing the square form. So we're all used to seeing the quadratic formula or equation looking like this. We call this standard form. Before I can teach you how to solve by completing the square, you first need to learn, well, how do I rewrite this into completing the square form, okay? So our standard form is ax squared plus bx plus c. We need to rewrite that into a times x minus h squared plus k. So this has all these new numbers, new variables that we have not discussed. So today I'm just going to take some time to teach you how do I rewrite it from standard form into completing the square form. Now, before I teach you how to go about rewriting it in that way, I'm first going to prove to you that these two are equivalent to each other, okay? Because right now they look nothing alike. The left side has a 4 and a 15. The right side has a 2 and 11. It's really confusing. So I'm going to prove to you that these two things are equivalent. We can rewrite this into this, and it's still the same exact equation. And the way I'm going to prove it to you is just simply by expanding the equation on the right. So I've got x minus 2 squared. I could rewrite that as x minus 2 times x minus 2 plus that 11. We can just bring that down, plus 11. Because we know x minus 2 squared would just be x minus 2 times x minus 2. So at this point, now that I've written it this way, I'm going to actually do some distributive property here. So I'm going to do x times x, and I get x squared. I'm going to do x times negative 2, which gets me negative 2x. I'm going to do negative 2 times x, which gets me negative 2x. And I'm going to do negative 2 times negative 2, which gets me positive 4. Don't forget to bring down this plus 11, though. Okay, so I'm going to bring that down as well. At this point, I can go ahead and combine like terms. This negative 2x and this negative 2x are alike, so I can combine that into negative 4x. I'm going to bring down this x squared. There are no like terms for that one. And then we've also got these two like terms here, this positive 4 and positive 11. And when I combine those, we get positive 15. And lo and behold, after we do some distributive property and combining like terms, we have the same exact equation as it was written in standard form. So that was just to prove to you that this form and this form are equivalent to each other, okay? What you need to learn now is, well, how do I rewrite this into this? Because once you can rewrite it into this, you are going to be able to solve for x using completing the square, okay? So the next video will go more in detail in terms of how do I rewrite the standard form equation into the completing the square form of the equation. As always, if you have any questions, please don't hesitate to reach out.